7.3 Addition and subtraction of rational expressions. So adding and subtracting fractions is the hardest. This section will definitely be at least 2 videos long, so bear with me. So let's review adding fractions. You need a common denominator. If I took 1/5 and I add 2 more fifths, I'm going to have 3/5. So once I have my common denominator, I add the top, keep the bottom, and then simplify if I need to. This is in lowest terms, so I don't need to. Down here, I have the same like denominator, common denominator, so I go ahead and add the top. Now when I'm adding the top, I'm just combining like terms. This is just 3 and 8, so it's 11, and it is simplified. Here, I have a common denominator, but 3x take away 1x is going to give me 2x's over the same denominator, and then I need to simplify. I have that reduces to 1/2, so I have x over 2y is simplified. Sorry about that, I cut that out, so it's x over 2y. I don't need the 1 in front of the x. So here I have a common denominator. I'm going to combine all my like terms. This is addition, so I'm just adding everything together. I can add x squares with x squares. So 2x squared plus 7x squared is 9x squared. My 5x plus a negative 5x, those are going to cancel out. Negative 7 plus positive 6 is going to be a negative 1. All over 3x minus 1. Now, this is factored completely. This is not factored completely. I have a difference of perfect squares. So I'm going to go ahead and factor. After I factor, I notice that I can simplify this. So I'm left with 3x plus 1 over 1, and I don't need to put it over 1. I leave it like that. You have to be careful when you're subtracting, when you have more than one term up here, because you're subtracting everything in this numerator. So you have a common denominator, so it's going to be 6t minus 1t will be 5t's. Negative 7 minus negative 2 is going to be negative 7 plus 2. So it's minus 5 over t minus 1. I'm going to say that again. Minus a negative is addition. I have to subtract everything in this numerator. Now, I'm going to pull a GCF of 5. They both have a 5 in common. Out, parentheses, t minus 1 over t minus 1. And it can simplify to just 5. Alright, now we're not always going to have a common denominator. So when you don't, you need to find the least common denominator. You want the smallest one that they have in common. So if I had 1/2 plus 4/5, a 2 and a 5, they're both prime. They both go into 10. So 10 is the first multiple of each of these numbers. So there's 2 times 5 gets me 10. So I do the same to the numerator, 5/10. 5 times 2 gets me 10, so I do the same to the numerator to get the 8. Then I add the top, keep the bottom, simplify if I need to. Now we're going to have to choose common denominators of expressions, and we're going to have variables. For example, if you have 9a squared and 12a to the 4th, if you notice, if you factor them out, this one has 2 3's and 2 a's. This one has 2 2's, a 3, and 4 a's. You need everything for your common denominator. So we're going to need the 4 a's. I need 2 3's and 2 2's. And it comes out to 36a to the 4th. So the first number that 12 goes into, that 9 also goes into, is 36. And I need the highest number of the variables that they both have. So here we're just going to find the lowest common denominator of these rational expressions, of these messy fractions. If I have a 6 and an n in my denominators, my lowest common denominator is going to have each factor. It's going to be 6 and n. Over here, I got a 10x and a 12x squared. 10, 20, 30, 40, 50. These are my multiples of 10. The first one that 12 goes into is going to be 60. So 60 is the lowest multiple that 10 and 12 go into. When I have variables, I need the highest exponent so that they both fit in here. So my lowest common denominator is 60x to the second. All right, here, now we have to make sure everything's factored. And they are. This is a factor of t, this is a factor of t plus 1. These are completely different factors. My lowest common denominator has to be each one. Imagine if t was standard for 5. This is the number 6. It's completely different. So you need each piece for the lowest common denominator. Okay, here we're choosing the lowest common denominator. Well, I have to factor these completely so that I can see each factor. Here I have a common factor of a 3 and an x. Pull that out. 3x times x gets me 3x squared. 3x times negative 1 will get me negative 3x. Now that's factored. Here I'm going to have two parentheses, x, same sign, both negative. Two numbers that multiply to 1 that add to 2, 1, and 1. So my lowest common denominator has to have a 3x and 2 of these. That way you'll see each denominator fits into it with no extras. Here, these are factored and they are completely different factors, so my lowest common denominator is going to be one of each factor. Example 6, similar to this, I have to factor completely first. And make sure I have each piece. I need the 2n, and I'm going to need 2 of these. Not 3. No extras, but I do need the highest number that this one has. It'd be like 1/2 and 1/4. The lowest common denominator is 4. This one has 2 2's. So let's do an example of actually adding or subtracting messy fractions with uncommon denominators. You first have to choose what your lowest common denominator is going to be. So if you have a 5x squared and a 6xy, the smallest multiple that they both go into is going to be 30. You need 2 x's because this one has x to the 2, and you need the y. So that's going to be the lowest common denominator. So to get to this lowest common denominator, you have to determine what is missing from each one to get there and multiply the same to the numerator to keep it equivalent. So 5 times 6 gets me to 30, and I'm missing the y, so I need 6y. Whatever I do to the bottom, I do the same to the top. So this will be 3 times 6 is 18y. Here, 6 times 5 will get me to 30. I need one more x, and I do not need a y because I already have it. So just 5x. Whatever I do to the bottom, I do the same to the top. So I'm multiplying this to this numerator. But I have two terms. I have to distribute it. So it'll be 5x squared plus 5, which I didn't do till down there. I don't know why. So then, now that they have a common denominator, you can combine the numerators and simplify if you need to. So we're going to end up with this 18y is the only y term, plus 5x squared, plus 5x, whoops, I messed that up. And there all unlike terms, so you can't combine them, so you just list them all next to each other. And you cannot simplify. So page 34 is adding and subtracting rational expressions. This is where we're going to pick up the next video for 7.3 part 2.